Nathan Sobo has unfinished business. He was one of the developers on Atom, the text editor that came out of GitHub. And Atom had a lot to like about it. It looked great, it felt modern, and it was really starting to get some traction when GitHub got acquired by Microsoft. And Microsoft didn't need a text editor. They already had VS Code. And so the axe fell. These days, Atom is no more. But Nathan's desire to build the perfect text editor, that has remained. So now he's putting everything he learnt from building Atom into a new editor called Zed. And Zed is very ambitious. It's worth looking at. So in this episode of Developer Voices, we're going to talk about what it takes to build a text editor for programmers. Which algorithms matter? What fundamentals do you need to know before you start building? Which language should you pick? Atom used JavaScript on Electron, and that was easy to make pretty, but much harder to make fast. Zed has chosen Rust, which is easy to make fast, but can you make it look good too? And even if you manage the job of making a great editor, you still have to think about adoption. How do you get new users? How do you pry people away from their existing editor? Do you need to have an extension language? Should you add collaboration tools of some kind? Should you specialize? Should you aim at day one to be the best Rust editor in the world? Or are there ways to support lots of different languages really well early on? We're going to find out the answer to all those questions and more. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Nathan Sobo. Joining me today is Nathan Sobo. Nathan, how are you?
I'm having a blast. We were having a good time talking earlier, and excited to have some of it on tape now.
It's cool. I think you're the first guest that's in their garden with a view of the mountains behind them, so that's nice.
Yeah. There's a couple power lines in between, but overall, it's still pretty good.
Well, this is mostly radio. We can't hear the power lines.
Nice.
That's got to be a good, safe thing. If you can hear them, you're about to die, I think. Anyway, we are not here to talk about power lines, but the lines of power that have been drawn through your life. How's that for a link? I was tempted to ask you why you're writing an editor, but you've got such form in writing editors. Really, the question is, what are you doing with your latest editor? What's your unfinished business in the world of programming editors?
Yeah. I feel like the why did you decide to write an editor was sort of for the first editor. And then this editor is because things didn't go entirely as I wish they would have with the first editor. When I set out to write, that was Atom. When I set out to write Atom, I had an editor like Zed in mind, but I did not have the ability to actually accomplish that. I had so much to learn. And we also picked a technical stack that was extremely challenging, not impossible, but extremely challenging to deliver an acceptably performant experience in.
So that's a review of Electron as a platform, right?
Yeah.
Tell me about that.
Well, the only tool that really felt easy to reach for when thinking about building an extensible cross-platform editor that wasn't something we would have been building ourselves. For us, and maybe this was our bias, like coming out of the Web 2.0 generation or whatever, but for us, like a browser environment, like browser tech actually felt like, if I could just use browser tech and then put a desktop application power veneer under that.
Yeah.
I know I can ship an experience on all the platforms that will work. And so that was one thing driving it. But what scared me from the beginning, I almost didn't even join to do it, was I was worried that web tech would be too slow. And I think the way we approached it in Atom, it actually was like we opened up too much extensibility and it was just too slow with the extensibility we opened up, and like we were sort of unable to wiggle out of it. But anyway, ultimately we decided like we can't go down this path any further. Like yes, WebTech has opened up this opportunity to ship this on every platform and have familiar tools and let people malleate it. But none of it matters if it's not the original vision that I had, which was an editor that felt a lot more like TextMate. It's like I wanted like TextMate,
Okay.
but powerful. Does that make sense?
What
Yeah.
is it about? Because I've never used TextMate, and I can understand why you want to add more power to it. But what was the core experience that was so good?
For me, I experienced it as very fast. Like I remember when DHH busted out TextMate. That was where I was exposed to it in his original Rails thing, where he's
Right. Yeah.
doing, here's how you auto generate this stuff or whatever. And at the time I was like fascinated with Lisp. I was fascinated with all these other things, but I'm like, dang, that's a pretty cool experience. It's so simple. There's nothing. It's just this dumb editor that he's typing it into. And when you use that editor, the tactile experience felt responsive, but it did nothing. Of course, you were using a dynamically typed programming language. So the fact that it did nothing didn't really matter because there was nothing to do. Yeah.
Yeah, I know what you mean. Yeah, it's like when you hit everything's going to happen when you hit run, right? So maybe the editor doesn't have to be so smart for it to feel good. Is that where you're going?
Right. And so I wanted that experience. I think a lot of people that want that responsive experience, they are adopting Vim, right? They're going back to an editor that was written for so little memory and so little CPU that it's just inherently performant, or it's easy to be made performant. And I did, I wrote Atom in Vim actually. So I did go there for a little bit. Yeah. Until I finally but then I got the bindings kind of ripped out of my hands because we didn't have Vim mode in Atom. That was not the first feature that we implemented. And I went back to Emacs bindings where your pinky's just always down.
Destroying the hands of a generation.
It's not ideal.
Yeah.
and I sort of have the greedy algorithm running where to go back to modal editing is going to introduce this like temporary slowdown, and I just keep not being willing to absorb that, but I really want to. Yeah.
Okay. So, I think my very first job, the CEO there made everybody learn Vim. Even like the company secretary had to learn Vim. So there was no choice, and it got steeped in you quickly.
Wow.
But I can understand why maybe you never jumped on that modal editing bandwagon. That doesn't leave you a lot of choices for a really fast editor, does it? Certainly not at that time.
No. I mean, and I think Atom, Microsoft bought GitHub. Atom was sort of, the writing was on the wall, and I was over Atom because I felt like I needed to start from a new foundation anyway. But I was left in this little void period of like, okay, I don't have to keep doing text editor stuff. I really don't. I could work on something else, and so I explored some other stuff. But as I did that, I'm like, okay, but anything I'm going to do in software. And there I was in Visual Studio Code at the time. And now, could I have been in a different editor? Could I have gone in and adopted Vim, NeoVim? I think the answer is probably yes. But I just felt like, there's so much I know. There's so many mistakes I made that I can make up for. I have so much more knowledge about how to actually structure the design of an editor that is actually the thing I want, which isn't, for me, going back to, for me, it is a kind of a GUI, a graphical editor, not a terminal editor, but in all other respects, sort of has the same vibe of a highly, a tool geared toward experts, but graphical. And anyway, the cursor just sat there blinking at me, mocking me. It literally, I think I've described this maybe on one other podcast of like just sitting there. And I think I was implementing like elliptic curve cryptography. I was like, well, let's explore cryptography. Maybe there's something there. And that was like writing a slow version of elliptic curve cryptography in Rust. And just watching that cursor blink and just each blink, it's like,
Yeah,
do you want to
this
do
seems like a
this?
very natural programmer instinct. Like you did it once, now you know how you should have done it properly, and that's always going to itch at you for the rest of your
Yeah.
career until you finally go at it. So I've dabbled myself in writing an editor, but I never went all the way down the rabbit hole. And I
Yeah.
certainly never got to the point where version 1 was done and I wanted to crack on with completely new version 2. So you know a lot about writing an editor that even younger you didn't know. Give me some hints about like what's the right way to architect an editor? What do you need to worry about? Which algorithms matter?
Right. Well, I mean, for me, the choice of tool really does matter. So I don't want to spend a ton of time on that. Maybe we can come back to it. But I think on an algorithmic level, something that has really mattered to me is mastering this particular data structure, which I think it's called a segment tree. I didn't know that at the time I sort of made it. That was long, so I called it a sum tree. But it's basically this data structure that's like a copy on write B tree, where B plus tree, because all the items are stored in the leaves. But instead of what we're summarizing up the tree is sort of the sum, the aggregation of all of summaries of all the items in the tree. And so it's sort of this persistent universal indexing data structure. So having that data structure has unlocked a lot. Yeah.
So am I imagining then if I open a text file in my editor, that's actually the leaves on a fairly deeply nested tree?
Not only is it the leaves on a fairly deeply nested tree, but it's also been filtered through the leaves of, 5, 6, maybe, I don't know, maybe that's over exaggerating. A few, I don't have a count, different trees that are sort of in charge of efficiently translating, a point in the file to but now we've injected synthetic soft wraps. Now we've folded text. Now we've expanded tabs. Now we've injected inlay content. And each of those intermediate structures, which is used to map that point, is also expressed as as the leaves of one of these trees, basically, which is an efficient index on a sequence.
Okay. So if I look in this tree, I'll see something roughly like this is a fold of a block of code which has a blue thing, which is actually the characters FUN for function.
Right.
Is
like
something like that?
Something like that. Yeah. Like inside that, in our structure, we have the fold map. And the fold map, has a sum tree of a bunch of folds. And for each fold, there's sort of in the output coordinate space, how many rows and columns or offsets. I think it might be expressed as how many bytes are spanned by the fold in the output closer to the viewer, and then how many bytes are spanned by the fold in the input closer to the file. And so sort of we have a sequence of these trapezoids. So they're sort of trapezoids that are, isomorphic. Like they might be skewed in their relationship left and right, but you've basically have seasoned in these weird spatial transformations, and you can keep a running total on the net result of, there's a fold here, and then it's the same. And then maybe you could go the other way. We don't support that in the fold map. We separate that out. But there's a spatial transformation basically being expressed in the sequence inside here. And then by efficiently being able to seek in one dimension while summing in another, we can efficiently traverse that transformation so that we can say we're scrolled down to line 5,000 in the buffer. Where is that though? Because if we have a soft wrap line that's 3,000 lines long, anyway. So
yeah.
Anyway.
So this translation between the raw text and all the different layers that go on top of that into screen space.
Yeah. And it's really helpful to be able to interact with the index on that transformation in an efficient way. And so all the focus is on the rope. but the rope is just where the text is stored. There's all these other persistent structures that I think that we've discovered need to exist for getting the rope onto the screen.
I think you need to step back and define what a rope is.
Yeah. So a rope is a way of representing a string. The typical representation of a string is basically one region in memory, right? And we record sort of how long that region is and where it is in the string handle, and then it's allocated on the heap somewhere. And we've got this contiguous block of bytes. But if you're manipulating that a lot, or you get a really big one, imagine you have a string, a file that's 200 megs long, and you just want to insert one character. Are we really going to be moving memory? No. The answer is no. We can't move all that memory. So this direct allocated representation is not good for editing. What's good for editing is to take the string and break it up into these tiny chunks and then structure those chunks into a big tree. We use persistent trees, which like I'm sure your audience is probably pretty familiar with, like from functional programming talks and stuff, like
an immutable data structure.
Yeah.
Tree.
Immutable data structures. Our representation is persistent. You can imagine a mutable one as well, where you're basically, every time you perform an edit, we're essentially performing path copying, where we're recycling all areas of the tree that contain text that was unchanged. And we're, bounded by some, O logarithmic depth going down that tree. Anyway.
It's not unlike storing a file system on disk, right?
It isn't.
It's all broken up into little pieces and pointers to where everything is within a hierarchy.
I mean, I've never written a file system, but I am imagining that thered be,
I mean logically rather than practically.
And one thing that I'm excited to do is actually start persisting these persistent trees to durable storage. Yeah. And, starting to use that to go deeper in terms of what we can index and store. Because we also use the sum tree to store the sequence which represents the CRDT, which is like...
we have to get into CRDTs.
Okay.
Yeah. But that's a rabbit hole in itself.
Too crazy. Yeah.
Now, I want to get too crazy, but I want to do it in the right order.
Okay.
So there you are, becoming an expert in manipulating these data structures, which you must do. That feels like it's going to be a little bit painful in Rust. I mean, I don't know. You tell me, because like borrowing and passing things between functions, that feels like the performance ergonomics trade-off thing.
Yeah, it's interesting. Definitely when I tried to learn Rust, I was like, I gave up. I gave up for a while, to be honest. And then I tried again. And I've definitely gotten better at it. And it's definitely hard. The learning curve has been brutal and hard also just because like, how do I even express this in Rust didn't feel immediately apparent. Like reaching for paradigm or patterns, ways I had done it before was not helpful because none of those patterns worked. Yeah.
That reminds me of my experience learning Haskell, which has become one of my favorite languages. But boy, did I have to change the way my brain thought to get used to it.
So I don't know. I mean, I never mastered Haskell because, I'm really excited for Richard Feldman's language Rock.
Oh, yeah.
And we're hiring. Yeah, he's joining our team, which is going to be really cool.
No way. Richard Feldman's joining you.
Yeah. When I talked to him, honestly, one of my first conversations with him was on his podcast, and he told me about Rock. And anyway, I'm going off on a tangent. I'm really excited about that. But I think maybe coming from the standpoint of a functional programmer, probably it's a little like expressing UI and building these constructs the way that we are. Maybe it feels more verbose than it would need to be in a functional setting. For me, coming from, languages like JavaScript or C, C++, it's like I don't know, there's a little bit of ceremony needed to kind of use patterns that end up being good ideas anyway that make the borrow checker happy. But other than
Right,
that, I
yeah.
don't think it's not a huge deal. I mean, when I see
Okay.
how expressive things can be, like I started thinking like, oh my God, is the entire state of the application, a state monad, and like, starting to expand my mind into like even deeper ways of thinking about it. But for me, like, yeah, from the perspective of a day-to-day application development, being willing to use mutable state when we need it, it's like I wanted to emphasize like just simple structs. You can mutate if you want. You don't have to opt into any immutable world. Like it embraces the reality of what Rust is as a language, I guess, is the
Okay.
idea.
Yeah,
But
yeah.
is there room for some fancier functional language on top of all that system infrastructure someday? Maybe, but I think you can make Rust expressive enough to build these ideas out.
Yeah, I would certainly believe that true. And I would certainly believe that when you get there, it's very high performance. One thing that surprises me, though, in the choice of Rust is it's something I really associate with like low level C code, like if you want to do systems programming, ideal for an editor. I don't associate it with building graphical interfaces.
Right. And I think that's because there are Rust UI frameworks. At the time when we started, there were some too. I looked at them. They weren't very well documented. They were clearly changing a lot. And I'm like, well, the one thing I know I can do is just build it. And so I ended up, because you don't associate it with building a graphical interface.
Yeah.
Having to build that out to a certain extent. Not the only one, but building it out. And what I just like about it is like, it's simple. It's all in one language. That language is incredibly fast. And if you can figure out how to contort that language into doing what you want, it'll be fast. And now the question is, how do we make that ergonomic? And I feel like that's kind of a lot of what we focused on is like, what are some ergonomics of that are reasonable to make it super fast? But then, I don't know, it could be under some other language potentially.
Yeah. But when you say ergonomics, do you mean for you as the Z development team, or are we talking about the ergonomics of a Z user?
For us to develop it, yeah, exactly. Okay. Yeah.
Tell me about your UI framework, because having used Z, it doesn't look like it's written in a C-like language, right? I mean, it looks great, if I may say.
Oh, thank you.
So tell me about the rendering framework you've made.
Yeah, I appreciate you. Yeah, I care about how things look, and I think that deserves deep thinking. So I think and we've had a designer on. It was the three founders and Nate. He was our first hire. He was a designer. And sometimes he's basically had to learn to code, and he's gotten really good, which has been incredible. But like, so how things look matters to me. I want it to feel, and that doesn't mean like, let's slap some gradients on it and have it look awesome. It's like, no, let's have it be tasteful and put your content first. So I think that's driven the design of the UI framework of like, okay, in an environment where I care how things look, in the rewrite of GPUI, we introduced Taffy, which is this layout engine written by the Diaxis Lab guys, or people, I should say, the Diaxis Lab people. And that provides like a CSS-esque, it's pretty good, but it's not perfect. Like it's a community effort sort of layout engine. But it's like, can I tap into getting a Flexbox style and some basic inline block layout? But then I don't have the DOM. So instead of that, like we actually build out a tree of these elements, and they're allocated in an arena that we discard at the end of every rendering frame. And the elements sort of express a tree, and that is your one-time DOM for the frame, kind of.
Oh, okay.
If that makes sense. Yeah.
Yeah. And you just render that out. Is it? But that's I almost want to say a physical thing. It's not like a virtual DOM-esque.
No, I mean
approach.
well, I think you need a virtual DOM in the case where you're trying to diff. And the best way to like get the window from one state to the next is to like mutate some underlying structure. But if you can just get your DOM to the screen in its entirety faster than all of that diffing, then you can just bypass virtual and it can just be sort of, it's a DOM, but it's a DOM for one frame. Like you build it this tree of elements, then we walk the tree and they all register themselves with the layout engine. We perform the layout, then we walk the tree in a pre-paint pass, which we use to determine like things like occlusion, where because if we want paint to be sensitive to occlusion, we have this pre-paint pass, which takes care of occlusion. There's a couple other details. And then
occlusion
with all that
is one thing sitting in front of another, right?
Correct. Yeah. Exactly. Yeah. So it's like if I want to color the background of a button based on whether or not it's hovered by the mouse, I need to know whether it's actually hovered or because it could be occluded, which means I shouldn't give it a background color, but I can't know it's occluded until I pre-paint the scene. Anyway, that's a nitty-gritty detail of this larger idea of like, we sort of build this tree, we walk the tree in a couple passes, and then we discard it. We've arena allocated it, so it's not a huge deal, and we can do it really fast.
I can understand that, because coming from like web front end, that sounds crazy. But you think about people building games in Rust, having to do 60 frames a second, and they're not complaining about the speed of Rust if they're complaining about anything. So yeah, why not? Why not render your editor at 60 FPS?
And obviously we only do it when you edit it. We actually, after every edit, we'll render frames at 120 frames per second for, I forget what it is. It's not that long, a period of time, because if we don't do that, we discovered in this funny incident with another YouTuber, Theo Brown, we discovered that like ProMotion, which is a feature on the Apple the newer Apple laptops, downclocks the display. And so you end up not actually getting 120 FPS responsiveness out of it. So we actually render synthetic frames, but then once that little quiet, like that, warm up or keep warm period has elapsed, then obviously we stop rendering. We're not actually a video game, but the ability to re-render the entire window. My favorite demo, I was at Boulder Startup Week last week, and I just like was like, okay, everyone just come around. Like I can't show you this through like a HDMI cable plugged into a television. Like you have to look at my computer and just hold down the tab switch button on Z. And I have my keyboard repeat rate a little overclocked, so I like my life that way, and it's makes for a good demo of just right.
Yeah,
you could just see the editor burr, right? And it's like, yeah, if you optimize this around the assumption that we're just, and there's a little bit of caching here and there to like save power, but like if the assumption is that it's no problem at all to just like render the entire window at the frame rate of the display, that's a cool demo. Who really cares? But what it really means is like you can actually be positioned to consistently deliver like reliable responsiveness on the next frame.
Yeah. And it's a decent end-to-end test if because you're constantly changing the underlying buffer. Yeah, that makes sense.
And is that perfect? Do we have bugs? Yes. We it's not always perfect, but like it's a hell of a lot closer than a garbage collected single-threaded scripting language could deliver. I guarantee you that.
Yeah, I can believe that totally. So I have an image in my head of the text file I want to edit being turned into a tree with lots of annotations on it for all the various editing features, and that tree being turned into another tree for rendering.
Yeah.
Is that the right mental model?
Yeah, so you might want to just like love trees, but that's just computer science generally, right?
Yeah. It's reminding me of, I've been writing a lot of Lua in NeoVim recently, and they only have one data structure. It's basically a tree. If you want an array, build it with a tree.
Yeah, Lua is interesting. I've never written any. I studied it a little bit, but I've never written any. But I like the simplicity there.
Yeah. There's things to like about it. Lots of things to like about it. But that makes me want to come. So if I've got the rough shape of how I would build an editor in my head, that makes me want to come up into user space. And I think my first question is there a language in which one extends Z? Will there be?
Right. Well, I think WebAssembly is a pretty reasonable like language, meaning that's an interface that does impose some constraints on. Yeah, so it would be the WebAssembly components interface. That's where I'd like to start and see, will that work? How
Right.
much will we need to sort of, the worry that I have, and I just don't know, and I think even members of my team might be able to speak more confidently about this, but like, are we going to need some like sort of WebAssembly side library code? Can we just use the WebAssembly component interface directly? Or are we going to need to sort of sit in front of that, facade that interface on the WebAssembly side? And will we need to pick a language, basically? And in that case, it would probably be Rust, with obviously the ability to like switch to other ones. But anything supporting WebAssembly. So Rock, I mean, I'm excited to like experiment with that. I mean, we'll have the author.
Bring Richard's language in. You've got the expert in house, or about to have. Yeah.
I mean, I'll admit I've definitely been thinking about that of like, where Rock seems to shine, although I barely used it, and Rust falls down, is just the feedback loop time. Like that's the big hard thing about Rust, is how long it takes to compile. So that would be something discouraging my use of Rust in any kind of like official hosted API surface beyond the WebAssembly interface. But on the other hand, there's a hell of a lot to be said for monoglottism. Just like, it's all Rust. You learn one thing, you learn it all really well. Like, how far can we push that? But I don't want to do that to the point of being stupid. It's like, there may be a strategic move that we could take, but I think we'd want to take it very carefully. Going from 1 to 2 feels like a big deal, as anyone who's had 2 kids will tell you.
Yeah. I think I've been triggered. So I mean, this is reminding me of we've spoken briefly about this offline, but about Emacs. One of the things about Emacs is it's just there's one language all the way down. The language you extend it in is the language you configure it in, is the language it's written in.
Right.
Are you tempted to go into that kind of world where if you open the editor up to user space, why not open up the entire can of worms?
Like the entire can of worms in terms of giving them, what's in that can? What kind of worms crawl out of that can?
I mean, if let me give it a concrete example. So, having looked at Z, I don't think there's correct me if I'm wrong, but don't think there's currently a plugin for like Git support.
Correct. Like,
and inevitably one day there will be.
Right.
So how deeply integrated into the editor can that be?
I think it's going to be organic. There'll be more power than we have now, for sure. Yeah. Are you rendering custom UI? I mean, if we can build a scheme that makes that efficient, eventually, yeah. But like, I don't know. I want to be judicious about what we open up, when we open it up. There's some things that we should just build into the editor. It's fine. Like, not everything needs to be done in an extension. We can actually build things into the editor. And not everybody needs to use every single thing we build into the editor. Obviously, at some point, your binary gets ridiculous, but like, we have that valve, and we're an open source project. So like, we should never forget that we have the source. But yeah, over time, I'd love the extensions to get better. So what is that? That's about opening more API surface area into those components, or deriving some kind of scheme where these WASM components are, you kind of plug them in like you know what I mean? What does the API look like? Just designing that all is not something we've invested in a ton yet.
Yeah, but
want
that's
to.
fair. I mean,
Yeah.
it's to build something like this is a project of many years, and you have to choose which parts you pick first, right? One of the most important parts of startups is prioritizing.
Yeah, and it's really hard. And I think we have room to improve, honestly, on doing it. It's hard to construct a narrative that's coherent in the face of so many different people with such disparate needs. It's hard.
Yeah.
It's
To succeed, you need to satisfy a lot of programmers with a lot of opinions, working in a lot of different languages with a lot of expectations.
But extensibility, it's one thing I'm excited about. I mean, we're already, thinking about injecting it into like prompting, where just this is an opportunity of like, okay, let's make this extensible. We've got the WASM dynamic prompt. You can run an arbitrary script that produces the text.
Yeah. Well, that kind of leads us into perhaps a fairer question, if I've pushed that too far, is so in your priorities, extension is on the roadmap, but you've picked some interesting things to prioritize right now, like CRDTs, a few other things. Where does Z excel today?
Yeah, that's good. Where does Z excel today? Then where are we shooting? What's the next big improvement we're focused on? I guess where it excels today is we're really fast. I mean, we really are. Like, there's been a couple bugs where that's regressed here or there, but for the most part, I never experienced a delay using Z. And so we have that. We have really cool non-local editing experiences, which are this concept of a multi-buffer, and something we're going to be investing in further. Of like, imagine performing a search and having all the constants of that search or all the compile errors summoned to a single editable buffer, which you can perform a multi-cursor edit across if you wanted to, or address one by one. So enabling some powerful like workflows around, especially with compiler-centric languages like Rust, where you could just bring all the compiler errors to you in one editing session, one editing experience. Like a lot of times, like you can really work through errors with a level of efficiency that isn't possible in any other way.
Are you saying so when I get a list of compiler errors, I go through this list and jump to the place in the file where it is and then edit, then jump back to the list? Are you saying your list will actually contain a view into the file?
Yeah, you kind of get this portal into another location that's kind of embedded all within one document. What we have now is this thing called multi-buffers, which is sort of what I'd like to move toward or experiment with moving toward is more creating a solution that's closed under composition, where rather than sort of there's a buffer and then a multi-buffer, there's just buffers, and then portals from one buffer can be embedded in another to create these like non-local editing experiences. But for right now, the multi-buffer is the approach, and it does enable some pretty awesome refactoring patterns. Our Vim support is quite solid, I'm told, although obviously based on our earlier conversation, talk to Conrad about that, who's been working on it. And what you can do is like multi-cursor Vim, which, arguably maybe you could use macros for that instead, but it is a kind of a modality, a way of working that's particularly interesting. Our collaboration support is pretty awesome. We use Z to build Z with each other collaboratively pretty much all day long.
Oh, that's something we really need to go further into.
Okay.
Because I've seen a few web services take a crack at collaboration. I've seen a few editors try it, but I've not seen like a first class, let's work on a file together in our editor experience.
Yeah. So like in the lower left, there's a little icon with like people on it. You click that and that's your channel tree. We've made everybody a member of the Z channel by default. That's where we do our work, mostly in public. Like we have our meetings in public. We had a meeting about some of the AI work I've been working on with Antonio and Max. Just a public meeting. Anybody could pop in and listen to us talk. And the tree of notes is associated, or the tree of channels each channel is associated with some notes. I don't know that this is how it's always going to be, but then you can like kind of talk to each other in audio, edit notes, which are persisted on our servers as kind of like a lightweight project planning process, if that makes sense. You're sort of meeting, talking, sketching with these notes. And then into the channel, you can also share your editor. You can share your project. And once you've shared your project, anybody with access to the channel, there's guests, and then there's people with rewrite access, and they can follow you around inside your editor and edit. And they can also edit. Yeah.
And this isn't like, I'll push my repo to you and you have your own copy. This is more like a Google Docs, we're editing the same thing at once experience.
Yeah, it's for a different kind of interaction. Yeah, it's for an interaction where it makes sense to be coordinating in real time, I think, for the moment. We obviously, as we get into some of what I was talking about earlier with our persistent data structure, I think we could start to get into more async focused use cases where imagine this happens to me all the time. I see some piece of code, I encounter it. Maybe it's a change to some decision I had made, and I see it and I'm like, okay, there's probably a good reason, but why did you change that? Because I kind of like that or whatever. And
yeah.
I want to highlight that and just say, like, to the person that wrote it, just leave an annotation on the code. Hey, why'd you change this again? I don't want to like commit right now, push up, right? I want this more. But anyway, that doesn't exist yet. What exists now, I think, is just a great place to talk about code in real time with people, whether you want to write it with them, like that pair programming, or just do some like live code review and say, here's what I did. I find it's just often a lot more productive than like trading comments on a snapshot of the code.
Yeah.
As a way of communicating.
I think we're both old enough to remember before you even got that level of like commenting on a PR collaboration. And the only way to collaborate was to literally walk over to someone's desk. But there's definitely something beyond batting a pull request back and forth.
Yeah.
Which we need to get to as an industry.
Yeah, and I think we kind of did have it inadvertently when we were sharing offices more. Because like you said, you could literally walk over there and now you have a shared memory access, shared device access to the same state or whatever. You don't need a CRDT.
Yeah.
But as soon as you are somewhere else, like it gets a lot harder. Like now you kind of do need a CRDT.
Yeah. I don't want to go back to the office. I want that experience to be transformed into code for me.
I mean, I like it both, but I get lonely, but I'm at home right now. I could be in an office and I'm not. So
you could be lonely in an office these days because no one else is going in.
That's also true.
Yeah. So tell me about the implementation of that, though. Go under the hood for me.
Okay. So it's fundamentally like the editing is based, every buffer in Z is fundamentally a CRDT. What is a CRDT? It's a conflict-free replicated data type. What is that? It's basically like an eventually consistent data structure is, I think, a reasonable way to think about it. Data structures that you can build in a way such that they're eventually consistent. I do something to my copy over on my computer, you do something to your copy over on yours, and we swap some sort of data. And at the end, we see the same thing. That's what we're trying to build fundamentally. Now, I kind of wish, although hindsight is 2020, and I don't know. Yeah, I kind of wish we would have gone even harder in on CRDTs.
Oh, really?
Where we used them was on just the buffers. But I'd previously done this project at GitHub. I was not in a good place. It was kind of in that, what am I doing with myself phase that I was mentioning earlier, called Memo, where we tried to build a fully replicated CRDT for an entire source tree. I think we were going about it in some wrong ways in retrospect, but I just felt like I'd been burned a little bit by biting off too much complexity. So I was like, we're going to do the buffers as a CRDT, and then we're going to do the rest of it, like the file system and interaction with the language server, et cetera,
Mm.
It's just a simple hub and spoke design where like every project has a host machine. Um, that host machine uh, has access to the language server and the file system for the project that's being shared. And everyone else's experience is basically delivered via RPC to that host, project
Okay.
host. But obviously, you can't edit text via RPC. There's too much latency. But you can
Mm.
run a project find via RPC. That's fine, right? Like you
Yeah.
don't expect, you know, CRDT, and then we don't have to fully replicate the data. There are a lot of advantages to it of like, I can share my project and boom, you have the illusion that you have access to it. Some of it is being kind of RPC'd on the fly, but it's tricky to get right. I mean, we've had to write these randomized tests that the cool thing about Rust, I don't know if you've gotten into this with any of your other guests, but like the idea of an executor, the idea that their futures in Rust, async code, sort of has to be explicitly run on an explicit thing and you have control over that thing. The executor that's running your async code is not like attributed to the environment like it is in Go. You can actually like write an executor. And an executor is kind of like how that async code is run is a parameter that you control. And so what we've been able to do is actually build a fake executor, a test executor that where we create a server, we create our server, we create multiple copies of Z simulated clients, each running inside their own application context, but they all share one executor. And then we can do these like cross network like integration tests of the entire collaboration protocol and all the different combinations of things that can happen where we have full control over all concurrent operations are being randomized relative to one another with a seed. So we can be like, oh, shoot, on iteration 20,739, there was some freak thing where this took way too long, which might only happen like, once in a century.
Yeah.
But we're able to track that down and isolate it and fix it.
Oh, so you're doing kind of generative tests where you can control what the network would be like.
Yeah. Yeah.
Yeah.
That's a cool thing that Rust enables that
I didn't know that. That is cool.
Yeah.
Because this kind of concurrent networking code is notoriously difficult to get right.
And I've written concurrent networking code where you try to test it and you let there be noise, right? Like you try to write a test for this async code, but it's actually using the scheduler. Like it's actually doing IO. And it's like, then you find the bug, right? The only problem is you find it like 0.1% of the time on CI and it's not reproducible, which is hell. It just grinds everything to a screeching halt. So it's like with this approach, it's like we have a couple, but for the most part, we don't have non-deterministic tests. We have been able to effectively model non-determinism and then drive it with our own RNG.
Oh, yeah. And then when you find a bug, you've got the receipt, the seed that tells you exactly how to replicate it.
Yeah. And I think people do stuff like this with property testing. I mean, a lot of our stuff is like pretty brute force, like custom, bespoke, like we reduce the problem ourselves. I know there's like, fancier functional languages have like automated frameworks that do this, but I don't know. We've just found a very pragmatic technique of like isolating the non-determinism completely.
Yeah.
Randomized test that.
Yeah. This is reminding me of Tiger Beetle. They're doing that with Zig.
Cool.
But that if you want to do concurrency and that kind of thing without losing your mind, you got to simulate it in a controlled way, but a realistic way.
Yeah, and I like that. That's like it's like a different take on Rust is like, we are going to make sure that problems don't happen by construction. And it seems like if you're not going to do that, then it does seem like a cool like way to fight back against the potential pitfalls of that, or just like really invest in ways of detecting the problems and really good error reporting. And like, anyway, that sounds cool that it makes sense that they're pursuing that path.
Yeah. So give me give me some thoughts on how you construct a CRDT. I mean, that could be obviously that could be a podcast in its own right.
Yeah.
But what are the core bits of distributed editing?
Yeah. Surprise, surprise, it's a sum tree. It's yet another one of this same type. And the sum tree contains these it's not just one sum tree. There's a couple involved, actually. There's multiple indices that we need to be maintaining. But we're basically breaking the text up into these fragments. And once a fragment is inserted into the tree, it actually is there forever. So the structure only grows, it accretes. But you can delete text by sort of marking a fragment as hidden. And so say that I put my cursor in the middle of a paragraph, for example, of text that you wrote, and you highlight that paragraph and delete it, and I type that key. It's fine. We still know where my key goes because when we deleted your paragraph, we didn't delete it. We just tombstoned it, right? We just hid it. Yeah. And so over time, these structures obviously accrete. That's one of the challenges, I think, about persisting the thing to disk is that we'll need to kind of deal with that, find ways to deal with that accretion potentially. I'm not sure. Or maybe we find ways to just stow it off in parts of the tree that we barely access, and it's just there for archival purposes. Because the nice thing is, by accreting, you are able to sort of represent every state that the document has been in over time. But anyway, we divide the text up into these fragments. And the idea is that even if I'm inserting inside of relative to your, let's say you pasted a paragraph, right? And now I'm going to type a character. I can say, oh, I'm at this particular ID. We assign your fragment a unique ID that's unique across the collaboration. And then I provide an offset into that fragment. And so since the fragment never goes away, I can always find where that offset is inside the document. But the problem is the fragment could get fragmented, meaning you might have pasted that paragraph, but then come into the middle of the paragraph and started typing. So now you've taken what was one piece of text and sort of split that piece of text apart.
Yeah.
I don't know how much sense I'm making so far.
No, I'm with you.
Okay.
Yeah.
Okay. Okay. And so yeah, go ahead.
You're kind of pushing, you've almost got a cursor into a tree for each user, and they're being pushed around the tree by other editors.
Yeah, that is an interesting way of looking at it. Yeah, that's pretty accurate. We have these things called anchors, and an anchor is basically essentially an identifier for a fragment, one of these fragments that has an ID that's been assigned, plus an offset, and a bias of which direction that anchor should go if something right at that location was inserted. That's a cool, really powerful construct. It lets us sort of use these anchors in all kinds of interesting ways, to demarcate a region in the text in such a way that I can come inside and edit inside that region. And now the anchor ending the range of the demarcation is getting pushed downward. It's a really powerful tool that we don't only use for collaborative editing, is my point.
Yeah. I could see how, it seems like a very generic structure that could be applied in other things. Yeah. It's also making me think you have potentially the complete edit history of a project, and you have a really fast game speed rendering engine. Are we going to see the entire history of editing a project displayed on a board, at a conference? Just watch the whole thing evolve from scratch.
God, that's a great idea. I know we don't have that persistent history yet. It provides me yet another incentive to be we have part of it built, CRDB. There's a branch.
Okay.
But that's the dream. And also to be able to sort of, because once we have that, we have the backbone we have a new level of backbone. Right now, the backbone for social coding is commits, because that's just that's the lowest level of shared state.
Yeah.
And so
that's the
just
atom
sort
of communication among programmers.
Exactly. and that kind of defines what the interaction is like. That atom, and I'm excited to see like what the interaction starts to feel like when the atom of communication shifts down to like the character, like the keystroke, the or the paste. Obviously, you could paste multiple characters too, but like that will be. I don't exactly know what it looks like. I mean, I think we're getting a taste of it on the Zed team, of just we don't really use pull requests a lot. What we do is just talk about code. Like even if Antonio may spend the whole morning and I'll pair with him for like an hour, we'll talk about a few different things. I'll pair with him a little bit and get the flavor of what's going on. Maybe I'll come back later and solo. I soloed earlier. But like by the time that's ready to merge, like we both have seen all that code. We don't need a pull request review.
Yeah.
And we both contributed a lot more value to it than we could have had we been like trading comments on diffs or something. We're just talking to each other. It's a different experience.
Yeah, I can imagine that. So you're ending up with a kind of experience where it's almost like people dropping into a party. Is that what it looks like?
Yeah, I think that's very similar. Like we're hanging out in a channel and like I'll hear boop, 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 boop as people popping in. And we'll also even have like, it depends on the time. Sometimes people are very solitary, but there are other times where you'll see it inside Zed's channel tree, like a decent chunk of our company at any one time, like paired up in these channels. And then there's even times where like one channel will go visit another one. So both members of the one channel will just go, okay, let's go talk to them about that. And some people are like, oh my God, you're ambushing me or whatever. And that, I don't know. It just depends on the vibes. I think we're working on sort of how do we build those same kind of cues that you'd have in a physical workspace of like, okay, these people are busy, leave them alone. Providing more like ambient awareness, I think is going to be important to making this really scale well, but it still works pretty well, even the dumb thing.
Yeah, it's one of those things where if you enable a much richer experience than we currently have, there are going to need to be social and etiquette changes to go along with it.
Yeah, we're exploring all that on our team.
You need to get an anthropologist in to study you early so we can get all the data.
Yeah, I mean, Torsten is kind of an anthropologist, to be honest. Have you ever talked to Torsten Ball?
No, I haven't.
He's awesome. Yeah. Okay. But anyway, he's come in and he's a bit of an archaeologist, maybe, and a bit of an anthropologist of just like been talking to us about all the stuff we built. Because the problem is we're so busy building it, we forget to talk about it. And it's
classic
helpful
programmer problem.
Yeah. But it's fun to talk about and it's helpful, so.
Yeah.
So he's come in and really leveled us up in terms of a lot of the things he's talking about are something other people have done, and he's kind of being there as a really good documentarian, and I've been loving that.
Okay, so he almost is your historian and anthropologist on the team.
Yeah,
cool. This makes me wonder. So collaboration. I'm thinking about the differences between the way programmers work. You don't yet have the problem where everyone has a different bunch of extensions installed. You're going to enjoy that problem. But you do have, having looked through the list of extensions that Zed currently ships with, you've got a lot. You've got like covering languages I wouldn't expect you to cover. Like you cover Elm and Gleam.
Yeah.
How is it you cover that many like fringe or non-mainstream languages in a young editor?
Two big investments have paid off for us. One is our investment in really Max's investment, but something that was an investment of the Atom team as well, Tree Sitter.
Right.
We've been working on Tree Sitter, and how to apply it to integrate it. Tree Sitter's been baked into Zed from the very beginning, and we have the grammars available for those languages.
Give us an overview of Tree Sitter for those that don't know.
Sure. Yeah. Tree Sitter is an incremental parser generator. So a parser is basically something that takes a formal grammar in and then produces a program that can consume a stream of bytes and spit out a tree that describes how the stream of bytes relates to the tree that sort of, yeah, and there's different types of parsers. Tree sitter is what's called generalized LR. LR, it's like left to right, I don't know, left to right, bottom up. It's basically very similar in nature to these table-driven parsers that are very efficient, like Lex and Yak. But the difference is that it's generalized. You should get Max on, and he'll talk about it more intelligently than me. But the problem with these formal grammars is they can have ambiguity. And what tree sitter is able to do is sort of create these localized bubbles of ambiguity to permit grammar constructs that are quite a bit more liberal than what those compiler front ends like Lex and Yak enable. Okay. You're able to sort of express more complex grammar formalisms more easily. And it also produces a concrete syntax tree, which means that every node that it gives you back is mapped to a position in the source code. So that's a concrete syntax tree, which is obviously important for an editor. It also has very good error recovery because, again, the editor use case of, okay, this isn't making sense. Let me leverage my ability to generalize in the presence of ambiguity to generalize in the presence of errors. And so
you're going to have to parse source code that's halfway written, or halfway rewritten. Yeah. And it's incremental.
And it's incremental, which means you could pay, I don't know what the benchmark is, tens of milliseconds, maybe for a medium-sized file, big file. I actually have no idea. It's fast enough that it doesn't present a problem. But the reparse times are like in the single-digit milliseconds, like very, very frequently. Like 1 millisecond wouldn't be that rare, sub-millisecond sometimes. We still do it off-thread, meaning if reparsing takes too long, then we will still give you the interpolated tree where we don't reparse. It's important to never block, but it's quite efficient. And usually by the next frame, you'll have the next tree. So that's tree sitter. The next big innovation investment, I think, is the language server protocol, which is Microsoft's doing.
Oh, yeah.
Right?
Which is almost table stakes for an editor these days.
Right.
And for a language.
And it was like, in my mind, a very smart thing that they did to be like, how do we get a bunch of languages supported in our editor? Let's build a common protocol. Everyone's standardized on that protocol. But the cool thing is now we get to plug in on the other side of it. So we're benefiting a lot from that. And then we have a little WebAssembly extension that basically is, how do we interface to the language server? How do we run it and download it? And there's a little bit of cleanup that we do on some of the data. I'm not sure if that's included in the extensibility piece yet. I should probably figure that out. But anyway, a tiny bit of glue code basically is what we essentially express in WebAssembly now to sort of manage the interaction with the language server. And then we have the tree sitter grammar, and then some tree sitter queries, right? Like queries such as what should the outline look like? So if you hit Command Shift O, you pop up an outline view. What should we show in there? It's different for every language. So the language also expresses these like pattern match queries on the syntax tree, which is like, this is a function. I want this to be included in the outline. This is an impl, and that's different in every language and driven by the tree.
Okay, that makes sense. So if your language supports LSP, which it probably does these days, and there's a tree sitter grammar written for it, which there probably is these days, you can build two things and sweep up a whole host of languages.
Yeah.
That's, having heard it, I can't think of any other way an editor could be written these days, unless for single purpose, right?
Right. And I think we're very flavored by our Rust experience, but even so, like, I'm tempted now. It's just about getting the bandwidth to like start doing our own language specific things for super popular languages and doing it in a way that's tucked away and potentially, you could jettison it from the binary if necessary at some point. I'm not opposed to that, but we've also tried to be quite agnostic in our approach to things, language agnostic, and lean on things that are universal across languages as much as we can.
Yeah.
Because like languages are cool, and it'd be great if new languages had good tooling. Why not?
Yeah.
Yeah.
And I there are all kinds of programming personalities. I'm certainly one that likes to play with a lot of new languages, and like an editor that just worked for one or two mainstream languages would be useless to me.
Yeah.
Yeah.
I just write Rust these days, but I don't know. I might want to write rock after watching Richard Feldman's stuff, but
It
yeah.
sounds, I'm willing to bet that a year from now he will have got some rock in there. So this takes us on to like the strategy of an editor, because you're coming up with a new editor. It's mature enough now, is my impression, that you go to people and say, "Hey, try our editor instead of the current one you're using."
Yeah.
How do you get to market? How do you get enough users? One way would be to specialize and be like, we're the best JavaScript editor ever. But that's not the road you're going down. What's the carrot you've got on the end of your fishing rod? That metaphor's broken, but you know.
Yeah. I've spent a lot of time thinking about it. I've spent a lot of time thinking that was the answer, that we had to go deep on one language. But I don't know. So far, it's been like we build what we really want, which we still don't fully have, to be honest, and then try to give people like tools they need to solve their problems too. I don't know. It's a little bit of a like, I really want remoting to work. Why? Because I want to work on Linux stuff, and I want to be able to do that in a container.
Yeah.
And so I need that. So let's just build that. And it's also hopeful that companies tell us that they need that. It makes sense that they need that.
Yeah.
So I don't know. Yeah, I guess. Yeah. Is there a faster route though? Like, is there a shortcut? Can we get more dominant in one particular niche? Is something I've racked my brain around. And I think we probably could. Like, if we wanted to really go after Rust, I think we could make a bigger dent in putting a few weeks aside. You're literally doing the product planning with me right here. It's hard to figure out what to do next. What we're focused on right now is remoting, because a lot of people want that, and it's a blocker for a lot of people being able to work in Zed. It's just like my code, for reasons I cannot control, is not on my local machine. I can't use Zed at all to edit it right now until remoting is solid, and we're getting really close on that. So that's one big focus. Then the other category is like paper cuts, which is just, it's hard to even form of just like stuff that goes wrong for people, little things that don't quite go right. But then the next big push is, it's a good question. Like, let me pull up from my notes this week. What were paper cuts this week? HTML tag auto closing.
Yeah.
Right? Like, that's a simple little thing that people are asking for. A lot of people are asking for, because they're like, Zed's amazing. I just really needed to close those HTML tags for me. And so you might say like, we're focused on Rust right now.
Yeah.
It's hard though.
It's full of those little things that are like not deal breakers, but yeah, it'd be really, really nice if it did this one extra small thing.
Yeah, or for some people that is, yeah. So it was just so easy to do, and so many people were asking for it that we decided to do it. We have Kyle like implementing Jupyter kernel support for us.
I can see that being important to people.
And then a lot of the focus is on how do we use these language models?
When you say language models, are you thinking of like tree sitter grammars or large language models?
Large language models, right? Language models, because what I'm excited about is like we're building a text editor, and we have what is essentially like a universal text transformation function at our disposal. What are the implications of that? And like I have to explore that. I want to put time there. And so does that target a particular niche like Rust programmers or whatever? No, it's a little broader than that. It's kind of exploratory in a way. Like How do I want to interface to the LLM if I want to do like generative coding, where I'm having it maintaining control over what I'm doing the entire time? Yeah. I guess my take on it is like interacting with the LLM, I want it to feel like programming, because it kind of is like programming in a weird way. Like, what is programming? It's sort of feeding a sequence of bytes into a machine and getting it certain behavior out. Like, looks like sort of, if you squint, like crafting a prompt and feeding it to be generated into an LLM. But for me, it's like I want to feel the control given to me by that. I want to get leverage from that, not have the control abstracted away. At least at the moment, that's the level that I'm interacting with it at. And I've had moments where I've gotten the right things, programmed the right things into this input, that what came out the other side was like incredibly useful to me. And I've also had moments where I've had a terrible experience where I have not been able to craft a program that would give me an output that was useful to me. But either way, like, I'm the programmer, it's text. That's going to be like that's what the take I'm trying to push forward, and kind of feel like we need to, it's a real risk to not be investing there, I think, and figuring out, in a world where some amount of programs are generated, how do we keep control and make that fun? Yeah.
Yeah. I can see a parallel between collaborating with humans and collaborating with AI at the moment, because it's like it all happens in one way or another. It feels like you talk with someone on Slack and then you go back to programming. And it sounds like you're trying to make it, all the kind of shaping of the code happen in the same place.
Right.
Whether you're collaborating with a human or with an LLM
or an AI,
all at once.
100%. And I think right now, like, we're not anthropomorphizing the LLM. I have this appliance in my mouth that makes pronunciation of certain words a challenge.
That's a tricky word on the best of days.
Anthropomorphizing. We're just treating it as an LLM, which at its base is just text in, text out.
Yeah.
Like, that's the ground truth. But what is true is that, like, the CRDT features are great for integrating multiple streams of edits. You know what I mean? And so it's like, it makes sense. Like, we've built a feature for collaborating between humans, which I have no choice. Those are anthropomorphic. It is a human on the other side.
Yeah.
And the same constructs I've built to support that end up giving us a lot of leverage, I think, when it comes to how we integrate interaction with the LLM as another source of potential edits. And so, like, one of our models is like, you highlight text and you do Control Enter and you type what you want for an inline transformation. And it just transforms that in place. So I think, like, that experience is like, it's text. We're a text editor. You can sort of provide this transformation in place. It's not exactly, you're not pair programming with a machine when you're doing that. But when it's streaming the edits back that are transforming the text in front of you, we still want to let you move on and edit or go do something, right? And so in some way, you have this sort of asynchronous process that's providing the edits.
Yeah.
You are kind of collaborating with it, but we don't, like, yet. I'm not opposed to it. It just feels like, let's start with the basics.
Yeah.
It doesn't have the vibe of, like, pair programming with someone.
Yes, but it's a lot. It sounds like it's going to be a long way away from if you use a refactoring tool, it's a stop the world, make a change, come back thing, as opposed to a kind of, it's a stop the world, go away and do this thing, come back when that one specific thing is done, change.
And I mean, right now, we just rewrite it in place and that's it. What we're working on is sort of rewriting it in place and then just cueing you, hey, a rewrite has occurred here, a transformation has occurred here, giving you an affordance to see the diff if you'd like.
Yeah.
And then you can sort of, like, discard it which the cool thing there is we've written it directly into the buffer, but CRDTs give us non-linear undo history.
Yeah.
So we can just do it. And then if you're like, no, I don't want that, then we can discard it. And it's fine. We just undo the operations of that thing being inserted. So that's another place where like infra we designed to support collaboration is going to be giving us a lot of leverage when it comes to providing a good experience. But yeah, my flow is like you ask to do something and sometimes you sit there and babysit it, but other times you sort of go on and do something else and then you can come back and it's right there in the code.
Yeah.
That's the idea though. You're not waiting on a commit or something. That feels like a lot of friction.
Yeah. And so what you've done really, as well as building an editor, is you've built a platform for these kinds of collaborative edits with different entities.
Oh yeah, that's interesting. Yeah, that makes sense. Right. Yeah.
So I have two broad categories of question I need to ask you. The first is like, where do you think that platform will be 2 years from now?
2 years from now. Yeah, I think we'll have CRDB in place and we'll have widened the scope of the types of interactions that are possible from mostly synchronous to a range spanning from synchronous audio chats all the way to like leaving annotations on some corner of the code that was written a few years ago. So sort of expanding the scope of the types of conversations and the pacing of conversations that we enable. And I do envision us having figured out how to make LLMs a robust part of that experience, that a way that keeps you in control, but also gives you leverage at the same time and gives you room to experiment with what that looks like on whatever model is coming out the door. I'd like there to be a lot more extensibility in place so that people can solve their own problems, and for us to be having a potentially more like, more of some of the beachhead activities you've been talking about in languages like Rust and some of the popular languages, where we're really starting to take that second pass of, all right, we have full control of this thing. What can we really do? Now we have extensibility starting to cover more of the long tail of things, but like, how can we really support X, Y, or Z community in a special way beyond what we have now? So I don't know. That's a lot of promises, and 2 years is a long time, but
also a very short time. It's both at the same time, right?
Yeah. It's true. I mean, I think we can get that all done. But everything changes.
Not to give you another task on top of this, but do you think you'll open source parts of it, like the Rust?
It's all open source.
Oh, but do you think you'll like spin out a Rust rendering framework or a CRDT database?
I see what you mean. Well, right now GPUI is just in our repo. It's MIT licensed. We haven't put a lot of effort into like turning it into a sort of Django or Rails type thing, if that makes sense, which I think is a big investment. On the other hand, there is a risk of like being sort of those technologies that would be inside of Google, and then there'd be like an open source reinvention of it outside of Google or whatever. It's like at some point, if people want it and we just have that code in our code base, like, do they just end up taking those ideas and running with them? Is that a bad thing? I mean, maybe it's fine. So
I think it's a great thing to inspire people on projects that you don't want to necessarily take on yourself, right?
Yeah. So I don't know. The challenge, obviously, with a wider effort around GPUI is just like, it's going to be an effort. We already have a lot on our plate.
Yeah.
The opportunity is like, the more we get written in GPUI, the better. If people were interested in sort of taking it into their own hands a little bit, and even, it's permissively licensed right now, right?
Yeah.
Like, I would love to kind of take things back, if that makes sense. Like, I don't know. It's tough. I don't have it figured out. How do we account for the bandwidth of supporting additional clients on top of the UI framework?
Yeah. Yeah, a startup more than any other company has to focus and say that would be great, but we can't do it. And the fact that it's open source means if someone else wants to, they can.
Not only can they can literally build a closed source app on GPUI on our code today. Like it's Apache licensed. So, I don't know, maybe that's stupid, but that's how it is. And like, I think what I'm hoping is that if people start building closed source apps on GPUI, that they'll be interested enough in what is coming from us upstream to like maintain a openness and reciprocity so that we can actually get good stuff. Because I'm sure there's a lot that people would have to contribute to it as they started. Yeah, it's just, I'm open to it. I just don't know. Yeah, you could look at the GPUI.rs website to see the amount of attention we put into it.
Okay. And maybe in the future, someone will run with it and then collaborate back with you using Zed.
Yeah, that'd be incredible. Yeah.
So that's really the final question we have to ask. If someone wants to get started with Zed, what do they do?
They go to zed.dev. You can download the stable version. If you want to live dangerously, you can download preview. If you want to live more dangerously, you can build it from source. And you can also build it from source on Linux today. We don't have an official distribution because there's some more things, the T's to cross and I's to dot. But hey, you're on Linux. You can build from source, right? You can build stuff from source. And so, again, I think we're not ready to put our stamp of like, it's official, Linux is supported, but like it's getting there. It's getting pretty close.
I know it's on Mac. Yeah. Is it on Windows as well?
It's not on Windows. And the main issue with Windows is it's just so much different than Linux is from the first platform. Like Linux is a little easier because it's Unixy.
Yeah.
Slashes go the same way and there's some of the same ideas. There's work underway on Windows though in Tree. I don't have status for you on where it's at. I should have that too. But if you want to get started as a contributor, we have lots to do. We have thousands of issues. And come hang out in the channel also. Like you can pop in, listen to us. We need to make better affordances for sort of notifying ourselves and stuff, but it's at least a way to get a little bit of a flavor of like what's going on. We hired Bennett. He was just the guy from Germany that kept showing up, and we hired him. He's great.
Open the editor, lurk in the channels, and before long you could be drawn in.
Exactly.
Yeah, nice.
Yeah.
Awesome. Well, I think at that point we'll leave people to go and check it out. Nathan Sobo, thank you very much for joining me.
Thank you as well. Really, thank you for the opportunity. Appreciate it.
Great fun. Cheers. Thank you, Nathan. If you want to give Zed a try, either as an editor or just an excuse to see a really good Rust user interface in action, head to zed.dev and there's a link to that in the show notes. Also in the show notes, we mentioned the language Rock and the database Tiger Beetle. If you're curious about those two things, we have previous episodes speaking with the creators, so check those out. You'll find the links down below. As ever, if you've enjoyed this episode, please take a moment to click like, rate, or share, or all three, and make sure you're subscribed so you can catch next week's discussion. But until then, I've been your host, Chris Jenkins. This has been Developer Voices with Nathan Sobo. Thanks for listening.